Good evening, ladies and gentlemen. So nice to see a full house. Welcome to the national headquarters of the Theosophical Society in America. My name is John Chianchosi. I'm the Director of Public Programs. And at this time, I ask that you turn off your cell phones and other noise-making electronic devices. This evening's lecture is being streamed live, and I welcome friends watching through the internet. The Theosophical Society promotes study, meditation, and service. We encourage open-minded inquiry into the world religions, philosophy, science, and the arts. And we have a deep respect for the unity of all life. Our goal is to help people explore the spiritual path so as to arrive at a deeper understanding regarding the wisdom of the ages. Furthermore, we feel that this wisdom is not limited to any one tradition, and thus we offer programs from all the traditions. If you have not already done so, I invite you to take one of our program catalogs, which are outside, and in there you'll find all the programs that we are offering during the next 3 months. This evening is the first lecture of our winter season, and it marks the beginning of our winter season program series. We are excited and happy to have such an auspicious start to our season by having a very honored guest. And I will introduce him to you just in a second. First of all, let me say that the Theosophical Society is a membership organization. Many of you may be members, many of you are not members. We are always happy to welcome new members. However, the programs that we offer here, together with all the resources that we make available to the public, are open to everyone. Please come and come often for any of the programs. Make use of the library, visit the bookshop, and visit the wonderful 40 acres of parkland. This time of year, not too good. In a few months, it'll be great. But as I said this evening, we do feel honored to have with us Bhante Samāhita. He's a Theravada Buddhist monk, and he has traveled from afar to come here for this occasion. So it is a privilege indeed to introduce him to you. Bhante Samāhita was educated as a medical doctor at the Copenhagen University in Denmark. He was also an associate professor in Bioinformatics at the Technical University in Denmark. And he worked with theoretical biology and artificial intelligence. He arrived in Sri Lanka in 2001, and there he became a fully ordained Buddhist monk in 2003. Living as a Theravada forest monk, he has been spending most of the last 16 years living alone in a remote mountain forest hermitage. His main philosophical interests is the convergence and the congruence of ideas within early Buddhism, Orthodox Quantum Physics, Einsteinian Relativity, information theory, and Thermodynamics. That's quite a combination of science and spirituality. And most appropriately, tonight he will speak on early Buddhism, quantum physics, and relativity. Please join me in welcoming Bhante Samāhita.
Thank you, John. Happy to see so many people here. Thank you for the introduction, John. Many of you probably know that John also has been a monk for 23 years, if I believe it so. So I feel really familiar with being introduced by a former monk. Nevertheless, during my university time, and also my time as a monk, I always thought that truth is one. And they actually asked the Buddha about this, whether truth is manifold or the truth is one. I think it's cumbersome to have something like spirituality of various traditions that says truth is this and truth is that. Then we have knowledge field of science that says truth to this and truth to that. If there's any truth to any of them, then they should converge on the same point. And this, I hope to demonstrate with this presentation, that actually there is some convergence between these traditions that are widely separated in time and space, and use different languages and have different purposes with explaining whatever they explain. But if there is some absolute truth in them, then they should converge in the very same worldview, even though this can be subtle and complex to understand. Just to mention briefly what is the worldview of early Buddhism, then one can sum it up by saying the Buddha saw reality as an experience. Reality is a frightening word, but nevertheless we have to embrace it and say, what is it from the different traditions? And he would point out that reality is an experience, and he would not say anything more about what this experience is. So he will say that it's a conditional relation between mind and its object. I'll come to later a speech where he clearly points out that. He doesn't say what is its experience of. He will say that mind cannot be separated from matter. She coined an expression called nama rupa, which basically means name and form. So this is internal name and form, and that is external name and form. This is internal mind and matter, could we call it in Western jargon, and this is external mind and matter. But his opinion was that you cannot separate mind from matter. And this is very foreign to a Western worldview, where we have the view that we can observe the matter outside of ourselves, independent of mind. So mind doesn't affect whatever we observe. But this is the Buddha will say, this is not possible. Mind is always involved when observing matter. The second thing that often was problem is that he had a statement saying sabbe dhamma anatta, which can be translated to reality or all is without a self, without a core, without a substance. This dhamma, translated as state, means a state that has both physical and mental aspects. So he says, this physical mental state, whether internal or external, is without a core. It's basically empty of substance, if not observed by mind. If we see what they want to ask him, what is the all? And then he would state very clearly that he will teach you the all. And then he said, listen to that, monks, what is this all? Then he would say, it is the eye and the forms, the ear and the sounds, the nose and the smells, the tongue and the tastes, and the body and the touches, and the mind and the mental states. This defines and establishes the all. If anyone, monks, should ever postulate this, having denied this all, I will define and point out another all, then that would be empty talk. Because if he was questioned, he would not be able to reply, and he would become quite perplexed. Why? Because, monks, that would be out of range. So his point of view is basically that you have a local reality, and that is what you perceive, what you experience. You cannot say what is behind this reality, like a noumenon in Immanuel Kant. What is behind the phenomenon? This is a metaphysical question. It can never be asked. What you have is your experience, and that is basically a local thing. He will furthermore deposit that when the eye meets the forms, then right there, visual consciousness arises. And this he will call contact. So this is basically what he says is all. So it's a very local, subjective point of experience. And what I'll demonstrate is that quantum physics, and to some extent also relativity, actually supports this view, to the big surprise of many. Here in USA, you had a philosopher, a psychologist also called William James, which has deposited a philosophical school called radical empiricism, which also, just like the Buddha, insists on subjective experience as absolute reality. So it's a kind of like a local thing. You can trust what you can see and hear, and that's basically it. As soon as you start assuming, then you're ascribing to a view and not to a reality. Niels Bohr as father of quantum mechanics, also from Copenhagen, has stated some similar statement in saying that everything that we call real is made out of things, atoms, that cannot be regarded as real. And if this don't shock you, then you haven't really understood quantum mechanics. The Buddha has, to some extent, said something similar insofar as he said that the world is bound up and shrouded by delusion. It appears as real, so he says it's an appearance, and is regarded as it were fine. The fool bound up by his elusive acquisitions, blinded by darkness, ignorance, assumes it as eternal, but for one who sees and fully understands, there's nothing real, stable, or ever same, neither here nor there at all. So they basically both insist that our naive local reality view is an illusion, and says the Buddha will furthermore state that what is not an illusion is your experience, and that what you can trust as reality. What about contemporary science? This is actually not that contemporary. This is from 1905, Special Relativity by Albert Einstein. He deposited something called length-contraction. And that is this uncanny feature that if one has a stationary observer or reference frame, and he measures this train to be exactly, let's say, 30 meters, then he will experience the train become shorter and shorter if it moves down the rail tracks with a given speed compared to the speed of light, until eventually that the train collapses and becomes a thin sheet of zero extension in the direction it moves, while its height is preserved. So here we have one observer. We could also have the friends of this observer inside the train. If we now ask these friends inside the train at the given time when it's accelerated up, please measure the train with a measuring tape, then they would find that in their reference frame, the train will still be 30 meters long. So this gives some validity to the Buddhist saying, or the Buddhist view, that reality is a conditional relation between the mind and its object, between the observers and what they observe. This one has to kind of like really wrap up, because the stationary observer and the observers inside the train do not get the same measurement, even though they are actually measuring on the same, what we will experience as the same reality. And so in this case, it's only because the train, the situation, the conditional relation between the object and the observer has changed insofar as it's moving with a speed that is comparatively fast compared to the speeds that we normally use. Can we find similar situations in the Buddhist text? And actually, yes, one can find similar situations. But first one can say they both speak the truth when we later decelerate the train and then ask them, what did you measure? And they answer 30 meters. Then it is both true that this one sees the train as, let's say, 1 meter of length, and they measure it to 30 meters. So their reality and this gentleman's reality is then a local thing. It is not something, we cannot say that it's the same reality for both these observers. If you go into the Buddhist text, there's some stories, but Mahamogayana is the left-hand disciple of the Buddha, who is a great mystic. And he has the honor of following two elderly devotees to the Buddha at a distance of 1 yojana, 1 league, and this is approximately 16 kilometers. And this was not possible because there were old people walking with a stick. So he made a superhuman trick to shrink down this distance to something like 50 meters, 100 meters. It doesn't say. But what the dialogue between the elderly gentleman and Mahamogayana says is that the elderly gentleman knows that he has to cross a river before he can come to the Buddha's monastery. And he asked Mahamogayana when he arrives at this monastery, when did they cross the river? And then Mahamogayana reminds him about a small stream. Didn't you notice the stream you were stepping over? So he had shrunk the length of this 16 kilometers down to a few hundred meters, so this elderly couple could come into the presence of the Buddha. This is, of course, a much more general feature that you can mind shrink distance. But again, it's if a conditional relation, if distance is a conditional relation between mind and its object, then mind should also be able to manipulate the distance. Another trick he makes is that he has to fight a snake being and then he makes himself very small, so he can stand inside the nostril of this snake. He also, at a given time point, stands inside the mouth of the snake. So this is an example of relativity in the Buddhist text that both in Einsteinian relativity, distance is not an absolute reality. It's like harmonica that can be, or accordion that can be extracted and collapsed, and similarly is it also in the early Buddhist text. What about time? Yeah, Einstein deposited in 1905 that there can be time dilation, and there is basically no simultaneity. That is to say, it's an illusion that you can have a block of space and that you have the same time in this block of space. But basically, time dilation means that if you have if you have a clock that you are accelerating, like here, a stationary clock and a moving clock, then time in the moving reference frames will start to go a little bit slower than the stationary clock. And there's a famous twin paradox that if a twin moves out in space with some considerable speed and comes back, then the other twin, in this case her sister, has become much older and wandering around with a stick. So again, it puts a dent in our naive reality that time is the same everywhere, and that you can have a block of space, for example, the whole universe, and if things are moving there, then still the time will be the same. This is not the case. This is not the case. Einstein himself, he gave a very nice example. He said that let's assume that there comes a 100-meter long train, and then you have one person sitting inside the middle of the train, and you have another person standing outside on the railways. And then two lightning hit exactly at the end of the train when this man sitting inside the train passes up the external observer. And then the man inside the train, because he's moving forward, he will see the light glimpse of the first lightning first. Because he's moving towards the light. So the light is coming with the speed of light towards him, and he's moving this way. So he meets this light a little bit before the light that is coming from the lightning that hits the back end of the train, that is, so to speak, trailing after. So he's moving this way, and the light is trailing after. So he would make the observation there's two lightnings. One first that hits the train first, and then the one who hits back at the back end of the train. While the observer on the train station that stands right in the middle of the train when the lightnings hit, he or she will see the lightning coming from two sides and hit where she's standing exactly at the same time. So when these two observers, one moving and one stationary, meet down here later down the road and say, was it wonderful, two lightnings hit the train, then they would agree, yes, two lightning hits the train. But the stationary observer will say, are they hit at the exact same time? While the moving observer will say, no, this is not the case. The frontal lightning hit first, and then the second lightning hit afterwards. And this means that these two observers, because they are moving, and despite the fact that they are doing correct observations, they cannot agree on the concept of simultaneity, that things happen at the same time. They cannot agree on it. And they make correct observations. So our naive reality, local reality, will more or less assume that there is the same time in the entire universe at the same time. But the fact is that because everything is moving with considerable speeds, the average speed is something like 20 to 200 kilometers per second, this means that there are actually no place in the entire universe that has the same time, that is simultaneous. So this means that one has to kind of like dig deep and transforms one's conception of reality, both regarding distances, length, and also regarding time and simultaneity. It doesn't exist. Another thing that is usually causing some difficulties to understand is the thing called gravitational time dilation. And this comes from the fact that if one accelerates a thing, then it looks like gravity. One cannot, a person falling inside an elevator, for example, will not be forced by any gravitational force inside this elevator, and it will float around inside the elevator as long as it's in free fall. And this means basically that gravitation and acceleration is the same thing. And this has also been proven experimentally. And this means that since the gravitation is stronger at your feet than it is on your head, it means that time goes a little slower in your feet than it goes in your head. So this is really as close as it's come, huh? So normally we will say there's the same time on the entire planet, or even in the entire universe. But even at such small differences, of course, it's very, very little, but still that's the case. Can we find any example of time dilation in the Buddhist text? And also here the answer is actually yes. First, I have to explain that the Buddha said there are 31 levels of existence, and humans are level 5. I'm sorry. So there's plenty of room for improvement. And so he also explained that there is a time difference between these levels of existence. And he gave the following statement that 50 human years on level 5, Visakha, is 24 hours of the Katumarajika Devas, which is level 6. This is one level up. And 400 human years is 24 hours for the Tusita Devas. This means the Devas, or the divine beings which are content, which is level 9. And 1600 years is 24 hours for the Parinimitta Vasavati Devas, which is level 11. This is from the numerical discourses. So actually he would say that at all these levels of existence, which is thought of or described of at least to be on a higher levels, this direction, away from planet Earth, they have a time that goes much slower than our time. So this is also an example of time dilation. Another example you can find in the text is on the Visuddhimagga. This is a Sinhalese king that was invited up to level 7 by the king up there called Sakka, or what the Hindus call Indra. And he has a few minutes discussion with this Sakka king, and then Sakka says that to his helpers that he should take down to planet Earth, to the surface of the Earth, because otherwise his family would not be able to recognize him. And he returns to Sri Lanka again, and then he has been away for 7 years, his family tells him. So this is an example also of time dilation. How can this be explained? The Buddha used a word for a world system which is called Chakavala. And this can basically be translated as world wheel, or world circle, or world system, which is the usual translation. It could be both a galaxy, but since he says there's only one sun for each world system, then it's probably more than a solar system. And as you know, all the planets in the solar system, they are rotating in the same plane. And this means that since there are movement here compared to planet Earth, then there will also be time dilation because it's moving reference frame. So if you stand on planet Earth and compare it with time speeds out here, then there will be a considerable time difference. Another saying goes that when the Buddha is enlightened, then a person called Indra is coming and having a look, and then he's threatened by another divine being called Mara, and then he flees to the end, to the rim of this world system, says Buddha, and leaves his parasol out here, and then hides his eyes behind because he's very much afraid. Of course, if here one will assume again from naive reality, but there is the same time over this entire solar system, and that there is the same time over this Milky Way galaxy. But this is not the case, actually. The speed of time in moving reference frame, from whatever reference frame you're looking at, whatever other reference frame you're moving at, if there's movement in this reference frame, then time will be dilated, and the speed of time will be different. Another thing I toyed with is a so-called space-time onion, the time difference. If there was a space-time region that was rotating in a contrary direction to the next space-time region, then the time difference between these two regions, if you were an observer here measuring in this region, would be even greater. And this, of course, we will not be able to see because it's space-time itself that is rotating. Another interesting feature about if you if you go into the text and study what the Buddha said, or what the Buddhist tradition, I can say about time, then our conception of time is that it's a continuous thing that is flowing more or less like a river water, and is completely continuous, while it actually could be contiguous and discrete. And their Buddhist theory of movement has it that nothing is moving in a continuous way. They would say that these physical mental states, they arise and cease here, and then they arise and cease there, and then arise and cease there, and then arise and cease there. And then this will give the illusion or the appearance of continuous movement through space. What about quantum theory? Here's John Archibald Wheeler, a Princeton physicist in his younger days, illustrating this point that a classical conception of movement is that a particle moves from A to B, time is upwards in this graph, through a continuous movement. While quantum theory will describe it and have it that it's a series of quantum jumps. It's never found in between here. So it arises and ceases here, and then arises field with some uncertainty here, and the uncertainty will grow even further while it moves along this trajectory. For example, the electron, if the electron is excited while it's rotating or found in a probability cloud around the nucleus, then it will be excited to an orbit that is further out, and then at a given time point it will jump back, but it will never be in the intervening orbits. So either it's found here in this orbit, then it disappears from this orbit, and immediately after it's found in that orbit, and then a quantum of light corresponding to the energy difference between the orbits are emitted. So since there's no, one can then see of the color of light emitted from atoms, for example, in this light bulb, they will be discrete. They are not continuous. So if they were continuous, then one will find light of all the colors in between these energy jumps, but you don't. Spectrum from given atoms, they have spectral lines that are discrete. And this means that the electron either is here or it is there. It is never found in between. So in this very, can say, fundamental way, then the Buddhist theory of movement, which is discrete jumps from place to place, is in correspondence with quantum theory. Interestingly, Schrödinger, which described the mathematics, once said to Niels Bohr after they had went out into the forest, that if this quantum jumps was something real, then he would have nothing to do with quantum mechanics. So he rejected what he himself has used his entire life on, because of his opinion, this idea of discrete jumps without ever being in the intermediate place was absurd. But nevertheless, this is a fact. In the text, one can furthermore often see the Buddha traveling with his several hundred monks. Then it's said he comes to the river Ganges, and then instead of traveling over in several boats, which is a cumbersome all-day-long affair with as many as these people here, then as fast as a man stretches his arm, he disappears together with the several hundred monks from this side of the Ganges River, and then he's seen to be on the other side of the Ganges River. It's said to take something like the fourth jhana of concentration to go in and then to determine, as you say, now we are on the other side. So he was able to move himself and a company of monks from one side of the river to the other side of the river without ever being observed in the middle place of the river or being seen to be taking a boat. So this is another example of a macroscopic quantum jump, which is not observed in the physical world yet. But of course, people dream about it because that will be the realization of teleportation. Discrete time has another feature that is interesting. There's something called the Planck time in quantum physics, which is basically corresponds to 5.4 times 10 to the minus 44 seconds. So a very, very short time blink. So this reads as probably 5 times 100,000 billion Planck moments per second. And this is said to be indivisible, smallest amount of time. One cannot have so this is basically the quantum of time. So one cannot cut it over. So this is the minimal time point. What we don't know at this time scale, because it's not probable by instruments, is to say whether these Planck moments, they are lying side by side or whether they are divided. If they are divided, if in the intermediate zone, then it would basically mean that the world is, our existence, material existence and mental existence also, is blinking. So it exists here. If we take world 1, could then blink here, and blink here, and blink here, and it will still blink by this homunculus frequency. This could be only divided by 5, or even if we say but divided by 10, they only step down to 10 to the minus 44 or more 43. So one could have another world blinking here just in this phase and in this phase. And one could have a third one blinking in this phase without these 3 worlds ever being at the exact same time. So they would never interact, neither physically nor mentally. Actually, you can say this intervening space or time, it could be years, it could be a million years. We would never know it because we only exist here and there and there, and are only conscious here and there and there, and therefore will have no idea about or be able to measure with any material instrument how long the intervening period was. So this leaves an interpretation of reality being at least, or leaving at least the door open for parallel worlds. Parallel not in the sense of they are existing at the same time, because they are not, but they can be existing at the same point in space, for example here in the tip of my finger, without ever colliding with each other. Let's just say, because there's a story or there's information that the devas can see us and themselves, but we cannot see them. If their consciousness was sampling both time phases, or for example 3 time phases, then they would be able to see this as overlaid pictures. So they would see their own world, and they would see our world, and they could see the world of the ghost, for example. So just by changing one's idea from continuous time, which one's just by kind of like say this is how we subjectively experience it, to discrete time, which is what quantum physics points to, then parallel worlds is certainly possible in a very neat and consistent way. And there's agreement between the Buddhist theory of movement and this quantum jumps of quantum theory. Another thing I came across, and which I find impressive, was that the Buddha predicted the Big Bang and Big Crunch cycles. Most cosmologists today say there has been a Big Bang, there was a singularity of energy, very high temperature, and then suddenly expanded space, and it's keep expanding. And as shown out here, it has recently been shown that the expansion actually is accelerating. And now from here, from the Big Bang to where we are here, and this point of space is something like 13.7 billion years. And what the whole cycle will take is in the order of 100 to 150 billion years, but nobody knows, nobody have calculated this. And there's still also some physicists that say it's a possibility that the space will keep expanding, and then the temperature will go down and down and down, because everything becomes more and more distant, until you cannot see any stars, cannot see any solar system, and this is called the Big Chill. But I think most cosmologists today say it's a closed universe. It will start contract again, and then it will enter in a big crunch. That it is expanding actually was first something that our science discovered in 1929 with Edwin Hubble, that looked out in space with his binoculars and then analyzed the light that came from hydrogen from various parts of the universe. And he then found out that there was a redshift, that is to say, redshift is a Doppler effect that comes from light if it moves away from us. If the light source is moving away, then the light will become more red. And wherever he looked at all the places around him, then there was a redshift. And this then made him conclude that everything is moving away from planet Earth. And it's moving away with a speed corresponding to the distance between planet Earth and the galaxy he measured. This would require, Edwin Hubble here, of course, used a telescope, and he used a spectrometer, two delicate instruments. But the Buddha, something like 2,500 years before, in the Aganya Sutta on the knowledge of the beginning, which corresponds to the Genesis, the book of Genesis, actually, in the Buddhist Bible, which is 56 volumes. Then he said, there comes a time, Vasetta, when sooner or later, after a long period, this universe contracts, corresponding to the big crunch. But sooner or later, after a very long period, the universe begins to expand again, corresponding to the Big Bang. to that extent the universe re-evolves. So this, later called the non-steady state of the universe, this Buddha described with big accuracy something like 2,500 years before Western science discovered. Before that, at Einstein's time, they thought that space is basically one big stationary block that doesn't move at all. Until Edwin Hubble come to and found this, the Hubble's law. So furthermore, the Buddha also have explained what our cosmologists cannot say. For example, he would say, in the next universe, the next cycle between Big Bang and Big Crunch, there will be no Buddhas. And in the next universe, there will be 2 Buddhas, and they are named this and that. And of course, our cosmologists cannot say anything about who or what will live in the next universe. He furthermore described that during this contraction period, when, for example, we will see more and more because everything comes closer and closer, so we will see more and more suns. And then he says in this Aganya Sutta that when we can see 3 suns from planet Earth, then the ocean has evaporated down to approximately 1 feet. And when we can see 5 suns from planet Earth, then the temperature has risen so much so there's no fluid water on the surface of planet Earth. And when we can see 7 suns, then this big crunch nuclear fire will arrive. So he made fairly accurate predictions about how it will be. And this gives some, when one reads the text, one gets an impression about what range they are. But they typically say themselves, these Sammasambuddhas, of which there have been an endless row. We know the names of 24 of them before Gautama Buddha, the last one that lived from 563 to 483 BC. Their range is said to be incomprehensible by normal human beings. If one tried to comprehend, how could they know that? How could they know that without instruments? How can they know when you see this and that? Basically, either 2 states will follow. Either one will become mad or one will become confused. But I think this is a clear-cut example that a modern conception within modern cosmology, namely the Big Bang, Big Crunch cycles, can clearly be found in early Buddhist texts. Even one cannot find out how on earth he could know that. General relativity, 10 years later by Albert Einstein, tells us that gravity actually is a bending of space-time. So the moon is not held in by a thread and circulating around the planet Earth, is actually falling in a bending of space-time. One consequence of general relativity is this gravitational time dilation we have discussed. But another consequence is basically that you can have black holes, and we have one in the center of our galaxy, and this is in all galaxies also. And these black holes is basically the density is so high and the gravity is so high that nothing can escape from it. They have a so-called event surface where not even light can escape from. And this event surface has interestingly just been found to be a measure. The area of this event surface is a measure of the information of all that has ever fallen into the black hole. So this is a really interesting thing, I think, that the surface area of a black hole is basically made out of the information of everything that falls in. So it's kind of like displayed on the surface on this black hole. And this has made a contemporary physicist named Leonard Susskind to predict that our universe could actually also be a 2D universe that is displayed as a hologram. Just like the information is displayed of all the physical objects falling into the black hole is displayed on the external surface, then our universe could be on an internal surface. Which one? Yes, if you imagine a universe that is, maybe we can back out, a universe that is expanding all the time, then because everything is expanding also inside here and here, then there will be a point where these two are going from each other corresponding to the speed of light. And this means that there will be a region out at the external edge of the universe this will then start to recede away from us faster than the speed of light. So we will never be able to probe any space beyond this border. And then this will be the event horizon corresponding to the black hole event horizon that is around here. And then this information could be displayed on this like in a holographic way, and this will then make a basically 2D thing consisting of information look like it was a 3D thing, just like your hologram on your credit card looks like a 3D thing, though it is actually only a small 2D printed image that is on your credit card. This gives some you can say it shows some similarity to a statement that the Buddha once made to a person or an individuality called Rohitasa. Sorry. Rohitasa is mentioned as a deva that comes to the Buddha at night together with, there was many devas that do the first part of Samyutta Nikaya is basically a lot of conversations between the Buddha and devas, that is divine beings of various kinds, of various intelligence, and usually they said that they light up the entire Jeta groove when they come to him at night and stand by his side inside his hut and then wants to ask him a question, usually in a very poetic form. And Rohitasa comes and he has had a life project and he longs to go to the end of the universe, to the edge of it. And he can go something with the speed of thought, because if he can see an object, then he can move to this object, however distant it is, as quick as he can move his arm, stretch his arm. And this he has done it for an entire life of these many million years, but he never did any progress. He just came further out in space. So he returns to the Buddha and asks the question how he can actually come to the end of the universe. And then the Buddha tells him that he cannot come to the end of the universe by traveling. This is not possible. Because he said, it is just here within this 2 meters long carcase, endowed with conscious experience, that this universe emerges, manifests, and ceases. So this is a really remarkable statement that I pondered over for a number of years, that the universe is, what he says is the universe is a local thing. It is not something independently of mind out there, as we usually perceive it as. Now we change gear and go back to the law of karma, also another feature of Buddhism, and I heard today also of Theosophy. And in Buddhism it's formulated like this: all beings are born and created by their karma, by their intentional actions. They are formed, conditioned, restricted by their karma. They're owners of the karma, debtors to their karma, and inherit their karma. Whatever they do, good or bad, the later effects of that will be theirs only. And this accumulation, I have said in square pattern of probability, follows them like a shadow of the past that never leaves. This is basically, can we find something about in contemporary science, in quantum physics, for example, that reminds of the law of karma? Here the law of karma is illustrated as a local effect, local mechanical effect. He does an action and then he experiences the result thereof. But actually, karma should both be likened to a field. It is not local, neither is it mechanical. So it's a non-local field of probability. If you do something here, then the consequences, if you go to Mars and if you stay up there for 10 billion years, will still come into effect. And there's many examples of people that have done something in former universes, 91 universes prior to this universe, for example, giving a gift to a given Buddha there, and then experiencing the effect in this universal cycle. So the echoes of this probability, the standing echoes, can be very long-lasting. So a more accurate representation will be that it's an everywhere present and enduring probability field, even at very large time scales. Thus we have something in quantum physics that is the same. Yes, actually there is something called non-locality, or entanglement is something that Einstein protested together with Podolsky and Rosen, Einstein, Podolsky, Rosen, in suggesting this experiment, and then say, quantum physics is incomplete because this is absurd. If you measure something here in this region, then you will affect the result in this region, even though they cannot move any signal from here to there. Basically, the thing is that you shoot a photon into a crystal, beta-Baran-Borat crystal, and then you get 2 photons out. they do not, unobserved, they do not have any polarization. Polarization will whether the light wave is waving up in this plane or is horizontal, or can be actually at all angles. But the point is that when Alice, because quantum physics has it, Copenhagen School of Quantum Physics has it, that the photons, if they are not observed, then they are basically in a superposition of all polarizations. And this means also spin, for example. You can have a superposition will say that it has both a polarization that is horizontal, vertically, and all other possible angles. If it's spin, then you say it's spinning both one way and the other way at the same time. Is it in a superposition of all possible states, if unobserved? Only when it's observed, then it has a definite polarization. And this is what, if Alice measures a horizontal polarization, then Bob will suddenly measure, without any signal going from here to there, he will measure a vertical polarization because the net polarization has to be 0. And this is something that experimentally 20 years later was determined to be so. So this is one of the situations where we know that Einstein was not correct. He misunderstood the situation. Lately it has been found that if you measure something in one diamond in Delft University in Holland, then something changes in another diamond, the same situation, or the entangled state in the other diamond, valence electron, changes 1.8 kilometers away. And when you have clocks, then you can measure that no signal can go from here to there, even with the speed of light. And this means that when just measuring something, observing something, a physical system in one region of space-time then affects another region of space-time if these two situations are entangled. The generalization of that with regarding the law of karma is that some cosmologists, not all, but some will say that this state that is here before the Big Bang is called a singularity, that this also is a single quantum state. This entails that whatever we found out here, 13.7 billion light years after, this is still connected. This is still basically one thing. Though it's separated in space, just like these two things, which could be potentially spread as much as we like, one end of the universe, and Alice could be in the other end of the universe, we will still find when Alice measures something, then Bob's photon is determined to have a definite state. So this means also if we change something here in this space-time region, then basically the whole, all other quanta in the same, connected to the same single quantum state will change. And what you change when you take a decision, then you actually reduce entropy, you make some order, and this will then have, according to this theory, compensatory changes in the entire system instantaneously, without any signal going anywhere, basically because it is still one thing, one single quantum state. And this could be the physical background behind the karmic law. Another thing is wave-particle duality. If we should say it's a field of probability, then there is this strange thing that all particles that we are made out of, whether electrons or neutrons or positrons or even whole molecules, if one sent them through, if there were only particles and we sent them to two slits, then we should see two stripes. But if one sends electrons and even macromolecules at the size of insulin through two slits, then one gets an interference pattern. And the only way one can get an interference pattern is if what is sent through actually is a wave that hits both slits at the same time, and then the waves interfere with each other, so you get high intensity, low intensity, high intensity, low intensity. So this means that everything that we regard as local and particle at the same time simultaneously has a wave aspect that is inherently non-local. A wave is a field. It is something that is everywhere present. It is cannot be localized, while a particle can be localized. So it's basically, as the Bohr said, complementary concept of what matter and particle is. There will become a small video about this right here.
And here we are, the granddaddy of all quantum weirdness, the infamous double-slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So, they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits and it goes through neither. And it goes through just one and it goes through just the other. All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched. And it was here that physicists stepped forever into the strange, never world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
However, the double hole experiment's mind-boggling conclusions don't end there. In recent years, technology has allowed scientists to perform a fascinating variation of the test. Its results call into question our perception of time itself.
This is like a high-tech version of the double hole experiment. Electrons are being fired toward a barrier with two holes in it. But the scientists can delay their decision about whether to observe the electrons until after they've passed through the holes, but before they hit the screen. It's as though I'm on a baseball field, and there's a baseball being pitched toward the barrier with the holes in it. But my eyes are closed, so it goes through, and it behaves like a wave, but then, at the last second before it hits the screen, I open my eyes and decide to observe it.
At that moment, the electrons, in essence, become particles, and seemingly always were particles from the time they left the electron gun.
So it's as though they went back in time to before they went through the holes and decided to go through one or the other, not through both as they would have had they been behaving like waves. That's really crazy.
That's the enigma. That our choice of what experiment to do determines the prior state of the electron. Somehow or other, we've had an influence on it which appears to travel backwards in time.
So this underscores the fact that reality cannot be said to be observer independent. If the observer chooses to see whether they are local, which slits they made through, so he wants to sample local information, then the same quanta of energy will appear as particles. If he decides to look at the screen and sample non-local information, then they will appear as waves. What about ourselves, for example? Could we also have a wave aspect that is non-local? And then some macromolecules has also been tried. Electrons are very small. It also goes for protons and neutrons. But what about with a molecule of molecular weight of 9,000? And this is basically, this is phthalocyanine is a blue color, but it has approximately the same molecular weight as the insulin molecules in your body regulating your blood sugar. Does this also display this complementary wave particle aspect? And this actually, this should come a video of it here. Should do like this. No? It does not. Why doesn't it do this? Anyway, it actually do. Huh? Sorry?
Because we're watching.
Okay, yes. Good point. Good point. Let's see here if we do like this. Here it comes. One back and one forward. See, can you see the interesting fact? When it hits the screen, then it's local. You see each molecule hits at a given time point. But at the same time, at the very same time, you see that there comes more than one stripe. So there come several stripes. And this is a conclusion or signature that these several stripes, that there actually it's a wave phenomenon that is coming through. They shoot at the screen one by one. Then this is a collated video. Huh? So one can clearly see that there is a wave nature of this molecule. Here you can see the final picture of these molecules that are at the size of your insulin. When it comes through the slits, and between the slits and the screen, then it's a wave giving this interference pattern. But when they hit the screen, then it becomes local again. So this is the experimental fact that all molecules up to this size so far has been proven to have this complementary wave aspect, where actually, as long as it's wave, then it's not observable. It's basically a wave of what? It's a wave of probability. It doesn't have any weight, it doesn't have any macroscopic properties. It doesn't have any localization. We have no right to speak about what it is or where it is. And seemingly everything that we are made of display this very same feature. So quantum mechanics says that it's unobserved, then it's a wave function. If you see the position here on the x-axis and then the probability here, then the Schrödinger's equation will come out with a wave function, theoretically before you make the observation. But as soon as you make the observation, then we have it that the wave function is collapsed, and then you find only one value. If you then repeat the experiment 1,000 times and count how many you find here, then you find the majority at this position, the second most here, and hardly anybody here, and hardly anybody there. And this means that this curve, this probability distribution, is saying something right about a collective phenomenon, namely an example of experiment made in the exact same way. The mystery is then, and quantum mechanics doesn't say anything about itself, what makes this wave function collapse at the moment of measurement. This is called the measurement problem. And there are different schools, and I'm applying to a minority school, I have to say, in physics that is saying basically the statement that it's consciousness that causes collapse. So before it's observed, then every quanta is basically a probability field, it's a wave, it's non-local, it is not present in the entire space, but it's smeared out over a large portion of space. You cannot say it has a location, you cannot say either it has any macroscopic property whatsoever. As soon as a consciousness wants to observe it, then it collapses into a matter particle that has local properties and are observable like you and me and this painting and this room. This was suggested by Eugene Wiener, who got the Nobel Prize in '63, and John von Neumann, so it's called the Wiener-von Neumann interpretation of quantum physics, which reminds about the Buddha saying that all is basically a conditional relation between mind and its object, between consciousness and its object. One interesting, if one looks at the universe as a self-created loop, then Archibald Wheeler, he has made this famous drawing. And he says, he coined the new dogma, it from bit, because he says, if you have a number of observers, basically all of observers in the universe, when it's only probability, and they look at the universe, then they will manifest these physical particles to have location. And while they are this collective creation of observer-dependent, participant, observer-dependent creation happens, then the universe becomes thicker and thicker and thicker until you have what we see to present day. So he says, we are participating in bringing into being not only the near, but also the far away, both in time and space. So the universe can be seen as a self-excited system brought into being by self-reference, by an astronomical number of consciously selecting observers over an immensely long period of time. Just like a self-recursive, reflecting creative concept, similar to an endless series of receding reflections sees in a pair of mirrors facing each other. John Archibald Wheeler. So I don't know whether you ever seen two mirrors that are looking at each other. You see an endless row of mirrors in the one mirror, you also see an endless row of mirror in the other mirror. But corresponding to that nothing is there, but there's still a reflection of something. You can still see an image. This is an interesting cosmology, this participant-observer principle, because it reminds a little bit of what the Buddha say of that basically all has no characteristics in itself. It's a conditional relation between mind and its object. So one can see, could the universe be a representation, or could it be a collective projection? And the Buddha, he will say, yes, it can be. That this is a reality, and there's no other reality behind that reality. And as he said to Rohitasa once again, it is just within this 2 meters long carcase endowed with conscious experience that the universe emerges, manifests, and ceases. It reminds a bit by the Bohr-Einstein debate, which reportedly have had the following conversation. Is Bohr and Einstein standing outside there in a restaurant in Brussels during the Solvay conference in 1927. And then Einstein should have asked Bohr about this, who hold this Copenhagen interpretation of quantum mechanics. Do you really think the moon is not there when nobody is looking? And then Bohr should have asked, prove me wrong. And that's actually a fairly subtle and very good answer, because of course at the moon there will be many observers. So it will not go away by just one observer stops looking. But they say there was no other observers, and there only was Bohr and Einstein. Yes, then prove me wrong. The prove me wrong argument is that saying, if you want to test it and the moon is up there and it looks away, how would you test whether the moon is still there? You only have one chance, and that is to observe it again. But at the moment you observe it, then it will reappear according to this theory. So it is impossible not to to prove this observer-dependent reality wrong. Information is physical. I think we jump over that. I'll just go to the agreement between early Buddhism and quantum theory and relativity. It is first of all that reality is observer-dependent, whether the observer moves or accelerates. It changes the reality, it changes time, it changes length. That early Buddhism agrees with modern cosmology on the Big Bang, Big Crunch model, the non-steady state universe. That relativity and early Buddhism agrees on length-contraction and time-dilation. And it also agrees with the quantum physics that the microphysical reality, at least, is only definite when observed. When it's not observed, it has no definite position or macroscopic qualities. And then it finally will agree about the fact of non-linearity or entanglement represented in the karmic law and the entanglement of all physical states in the universe. Thank you. As a last statement, we can just say that Buddha Gautama in Dhammapada 1 is a famous poem, says that mind is a maker. Mind precedes all things. Mano pupangama, it comes first. Mind is a chief, mind is a maker. And thereby, if one speaks or acts with a pure mind, happiness surely follows along, like a never departing shadow. But the first statement here is his weight on mind as a creator, as a chief, as a maker. Thank you.
Thank you, Bhante. That was very thought-provoking. And we do have time for questions. I expect there will be a number of people with questions. Please raise your hand so that I can bring you the microphone and we can record the question as well as the answer.
Thank you for this valuable teaching. My question is, I think, a basic one. Is truth in its ultimate form the same regardless of the perspective of the observer, and is essentially a Buddhist monk and a physicist doing the same work, trying to understand reality or understand truth from a different perspective? And then lastly, how is comparing these different disciplines, quantum physics and Einstein theory and the Buddhist Dhamma, what is the value of comparing them? Is it to validate each, or to how does it serve your practice, and how could it serve ours by looking at it from these different perspectives?
For me personally, I would say that discovering that some aspects of quantum physics also and relativity also is found in early Buddhism has strengthened my belief in that this is a knowledge field that has some validity. Secondly, some of the things that are conundrums, for example, mind precedes all things, all phenomena. If you don't know this observer-dependent thing from quantum mechanics, then it's difficult to interpret how it actually is so. You'll have to take it for granted just of the statements. So I think it's mutually supporting each other, that there is some convergence on the very same, very subtle worldview of something created in between mind and its object, and not as a reality out there that is independent of mind. So this is an idea one has to give up. Your question regarding whether we are doing the same thing, I think it depends a little bit about which school you are, both as a monk and as a physicist. I think if they try to measure it, how many believe that there is a definite physical reality out there, and this is the role of the physicist is to delineate this, something like 80%. Something like 80%. And only 20% of physicists will say, but there is no definite physical reality. It's not our job to say what it is. It is our job to say, as Bohr mentioned, what we can say about it. It's not something that is as a definite physical reality. And as a monk, to give up the idea that there is something out there that is independent of the mind is a relief. And I think also it gives more room for freedom. It gives human beings a better chance, because then we have a creative chance to change reality, also in the physical sense. While if reality was just a self-running thing and consciousness was only something produced by a swirling of atoms, and basically it was determined by fluctuations at the Big Bang, then your and mine and others' free will be an illusion. It will be all determined already 13 billion years ago. That will be a dreadful and I think very narrow worldview. But that is basically the positivist or materialist worldview, that this is determined already in advance. Does this answer your question?
Thank you.
I think.
Well, thank you again. This is very fascinating. This is a simple question that everybody knows that you just proved, but I have another question that goes with it. There's an old joke, whatever story. If a tree falls in the forest and there's no one around to hear it, does it make any noise? And since there is no mind to contact that reality, then it would make no noise. I get that. But if there's no observer, and the tree is standing one moment, and then it's fell the second moment,
how do you know?
Actually be a falling, or would it just leap from one state to the other?
How do you know whether the state of the tree if there's no observer? You know, it's obvious that there has to be observer. Everything that you talk about, this change of state, they only makes, and that's the Buddhist point, they only make sense insofar as they are observed. Insofar as they are observed. And this also goes with all materials, solidity, fluidity, heat and motion. Only insofar as they are observed, and obviously only mind can make the observation. Then you can ascribe some reality to them. So the rest of the example, in your case also with the tree falling, there's a hypothetical tree in a hypothetical forest, and so on, is not observed. Yes, but if it's not observed, how do you know that it even exists? It's a pure hypothetical statement. So I have to say, I don't know whether there is a sound or not of non-existing trees falling this or that way. And also, I think it's not really interesting. But what is interesting is to see that quantum physics deposit that even what we know exists, energy, quanta, molecules, even insulin in my own body, that they also, if there's no observer, is basically a cloud of probability. And this I find highly revolutionizing, because it is not normally in chemistry, and also I've been educated as a doctor, we would think small balls that are circling around and they make covalent bonds and they have weight and properties. Yes, but whatever there is inside this room, if we bombard it through a double-slit experiment, well, then they will display wave aspects. And then one has to answer the question, waves of what? Waves of what? So while they are traveling from the two slits up towards the screen, then you cannot say where they are or what they are. And this also goes for everything here. And this one I think has to respect, because this is a new worldview. This is a new worldview, that basically you and I and everything here is a cloud of probability if there's no observer.
Excuse me for taking one thing on, but based on what you just said, is it like mass hysteria that we all seem to share the same reality, or
no.
How does that come about?
Yeah, that's an interesting question. Why do we see the same physical reality as multiple observers? I think the following. Since the beginning of time, according to Buddhism and reincarnation, has looked at the same physical reality, then our expectation will be the same, that a tree is green and so forth. So this means that when we collapse the wave function, the wave function we brings to the fore, and can say the expectation we have, so it basically could be illustrated as two wave functions that are superimposed, and then one observation will come out of it. Then I think regarding physical things, in our karmic reality, we don't have any differences or probability distribution a priori that is much different. So you have seen trees, and I have also seen trees. So when we in the next life, we will also expect trees to be vertical and green. However, it's another story with life beings. So other beings, there we will have emotional, one who has been our enemy for 10,000 lives, and another one has been a friend to the very same individuality for 10,000 lives. If they meet the same person, then they will not experience the same thing. Even though they have not experienced this person in this life, again, they will instantaneously ascribe two different emotional values to the very same experience. So there I think it's another story.
Could you speak a bit about how this relates to artificial intelligence?
I don't think it directly relates to artificial intelligence, but I can say something about artificial intelligence from my own work. I think it's something that one shouldn't play with, basically, because I remember I did artificial neural networks, and they are made to predict some various features in DNA strings and protein strings, and they were much better than me, and far better than me. They are far better at playing chess. They are far better than anything that you can train on. So I had various training sets. You train them just like you train a child. So my task was, because there was different distributions of data in the various data sets, I should invent a method, statistical method, that saying whatever I put my artificial brain on, then it should learn to predict on this data set with maximal accuracy. And this I succeeded in making such a statistical method. And then I came to think about this. I remember sitting at night and saying, now I got it, how to balance training out. So it's just about selecting data and balance all differences out from the data set itself. That hasn't to do with the causality. And then I thought, okay, you have such a method. Whatever a given neural network will experience in the external world, this it will learn perfectly at the minimal training rounds. And then I decide this is not something that you should publish. This is not something you should publish. Because if you put a robot with hands and feet on and has sufficient computer power, then it can learn anything. Whatever it experiences, you send it out in the external world, then it can learn anything it wants and be much, much, much more capable than we. This despite the fact that it is not conscious. It is not, we are conscious. We take ethical decisions. But it is not conscious. And this makes it completely unpredictable. And this, I think, is something that one should think about. And further down the stream, there's already, of course, made several films about it, of machines, man against machine, and so on. And I think it's not without a good cause. I think it's something that one should be very careful with, putting out the box, letting out the box, so to speak. Because they are so capable, so capable. We don't stand a chance, to put it brief.
During your fascinating talk, I had the feeling that every time you were talking about mind, you were talking about the human mind. When you said mind precedes all things.
Yes.
Or you're talking about the human experience with mind and matter.
Yes.
My question is, can you think about mind beyond the human experience?
I think it doesn't go only for humans. I basically think it goes for all things that has consciousness. And what beings has consciousness? That humans has, animals has consciousness. How far consciousness goes down? Buddhism has it, for example, that a plant like this one, even though it's a multicellular organism, does not have consciousness. Bacteria doesn't have consciousness. But worms, even at the microscopic scale, that is worms in your intestines that are not visible, fractions of a millimeter, they will have consciousness. They will experience. They will also be able to collapse wave functions and create local reality. So by mind, I mean everything that has to do with consciousness. And then, despite what many people think that in early Buddhism at least, plants does not have consciousness, even though they are very big and multicellular. They just cannot support consciousness. I had a little bit about what consciousness is. It's actually a really interesting question. Let's see here. It's called the heart problem. And I think, though the Buddha said it's one of the 10 questions that he will deny to answer, he will say this is the connection between the mind and the body is not something that can be answered. It's something that will cause discussion endlessly, and therefore it should be put aside. But I think it has been called the hard problem of this century. Buddhism will say that consciousness always has an object, and thereby consciousness is a bearer of information, it's a bearer of energy, it's a bearer of quanta, this small packets, undivisible packets of energy. And since it is a bearer, then consciousness must display this wave-particle duality. And the particle aspect, one physicist or a physicist student, he asked me about that. I think it's knowing one bit, basically, one bit of information. So it also, consciousness will display non-locality and entanglement. I'd just like to back up one, that information, I think, is a connecting point between the physical world and consciousness. That's why its consciousness is effective and can create karma, can create probability, basically. It's called Rolf Landauer's principle. He worked at IBM in '61, and then he said that erasing one bit of information produced a little amount of heat, and this was in 2015, proven experimentally. And this means basically that information is physical. It's an equivalent of energy, and thereby also that consciousness, that is a bearer of this information, also is a form of information. And then when you observe something, then you are tapping information from this system that has to pass a number of quanta from the object to you. And this means that it's by no means a passive reaction to observe something. And that's probably why you can collapse wave functions just by observing probability distributions. So this could explain, for example, collapse of the wave function. I'd just like to say that I think it's, the Buddha also say is that the mind is papasara, it is radiant, it's a form of radiation, it shines off everything, and it could be said also that papasara could mean that it shines from everywhere. So consciousness in Buddhism is a primary thing. It's not created by the brain. It's a function by the brain, just like you can say music comes out the radio, so also consciousness is modulated by the brain, but it's not a product of the brain by itself. It's a fundamental thing. One thought I've toyed with myself, since he says this is radiation, could we compare it to light, which is basically electromagnetic radiation that has a certain wavelength? So here you see, basically the theory is that it's a magnetic field that induces an electric field, and then it keeps waving around, and that's why it can propagate through empty space without any media. Then I thought, can consciousness also be likened to a form of radiation, just like light is electromagnetic radiation? Yes, if you could have a undulation in consciousness, then you could have the orthogonal undulation in probability. Why do I say consciousness could induce probability? Because dependent co-arising in Buddhism has it that sankhara, which could be corresponding to what probability is, induce vijnana, and vijnana induce sankhara, probability. So that this mutual induction you find in this model of consciousness is also is similar to the mutual induction between a magnetic field and an electric field. And if this is true, then everybody in here they have an emitter, just like your mobile phone has an emitter. It can transmit information through radio waves out, and it can also receive them. Same thing with your brain. It can transmit consciousness waves of another nature, which have a specific frequency. But in contrast to your mobile phone, which also has the same frequency, then you will have an individual frequency, each one of you, of which we don't know what the frequency is. No one can measure this at the current time point. But if we have an individual frequency, this will explain why I cannot experience your karmic results and you cannot experience mine. But we are still sending out probability. So we are walking around in each our probability valley and emitting the echoes of our own intentional choices and absorbs them just like you absorb light on your skin and become a little hotter at that spot. Then absorbing a wave of probability will corresponding to experiencing an event, both a physical event in the physical world, but also an internal mental event, whether being satisfied or dissatisfied, whether agreeing or disagreeing. So this could be conditioned events So this means that if everyone has an individual frequency, then it will explain why karmic responses are individual. Another thing that could also explain the collapse of the wave function, because one component here is probability, and if you disturb one field of probability with another field of probability, then no wonder that it collapses. It could explain out-of-body experiences, because now basically consciousness has a non-local aspect that is not only inside the brain, but basically all over space. It could explain transmigration during rebirth linking, the Parisanti Vijnana that ceases and dies here and then reappears in another being. And it could, as I said, explain individual frequency-based specificity of karmic echoes. Lastly, it could explain precognition of imminent danger. It was something that I experienced myself, and for many years has pondered. I told John about it. One day I was sitting in my garden, and then suddenly I had to visit my grandma. My grandma has 52 grandchildren, and I was her favorite. I loved her very much, and she also loved me, so we had a very, very close emotional connection and had for many years. And suddenly I lived something like 2 kilometers from her, 1.5 miles, behind a hill and behind a forest. She lived in a high-rise house. I was living in a villa. And suddenly panic gripped me one day, and I remember I pulled up my friend from a chair and pushed him out into a car and stormed around and drive up with screaming wheels up to her high-rise house and stormed up. I have my own key because she couldn't hear anything, so she couldn't hear the doorbell. And then I came out into the kitchen, and there she was standing with the back to me, couldn't see me coming in, and then kind of like I could see her hand move. She was kind of like fumbling with a lot of tablets on the table. So she eats too many heart medicine, digoxin. Then you get a slow pulse, low blood pressure. And right when I came into the room, she fainted and started falling backward like this. And then I came onto her, and she fell right into my arm. She never touched the floor. If you have asked me down in this garden, well, why is it that you have to visit your grandma? I'll not be able to answer. But I will answer, I don't know, but I had to visit her now. No. So I had enough information to act adequately in this situation. Though I didn't know what had happened, I could sense and act upon rationally, and actually it saved her life, because usually old ladies, they break their hip when they fall on the floor, and then they have to go to hospital, have a hip replacement, and they can get embolia in the legs, and then lung embolia, and then they die from that. So for many years, there I was a medical doctor, and of course, if I should look at it from a neurophysiological point of view, you have the brain, neurons, synapses, and so on. They would not allow any explanation about how information about this situation 2 kilometers away could happen in a way so I could get any information about it. So you have to kind of like respect, this is not something I read in a book. This is something I experienced myself, how to explain to myself what actually happened. How could this be possible, that I could know something about what will happen to my grandma? And I think this model of consciousness as a form of radiation that is basically non-local, and it's a composite of consciousness in itself or awareness of self and then probability. This can explain basically that this happened, because then my consciousness will overlap your consciousness. And this will explain not only that you will see me communicating through verbs and phonemes, and then you put into sentences, and then you interpret as meaning, but you will also have, of course, the non-verbal communication. But then what I claim is that there's a third channel of direct mind-to-mind communication that one use all the time, basically. And it can be especially attentive if one is very close to each other. Imagine, for example, people kissing, they will have very, very close information about what is the state of the other being, while at this distance we feel our presence fairly remote, but still present. So I think my ability to respond adequately on this situation is that if you have two wave phenomena, like this one swinging with this frequency, and my grandma is swinging with another wavelength, another frequency, then there's something called coherence in physics, that these two wave phenomena, since they are overlapping in all points in space, their abilities to change each other is depending upon this coherency. And this coherence, I think, was enhanced very much in my grandma's and my in my case, because we have been so long together and because we were so emotionally connected. And this is also what psychology says of one-egg twins, typically, or friends. It has been measured in experiments called the telephone telepathy experiments. Basically, Robert Murdoch, Robert Sheldrick, a lot of people told him they tried to call their friend, and then there was nobody home, or they were beeping. They was already taking the phone, and then basically because they are calling you, so you cannot come through. So he made this experiment, and I think it's still accessible on the internet. You put in 5 of your friends, and then the computer ring up to one of your friends and say, in a little while, your friend will call you, and then it calls you. And then you have to press 1 for Liza, 2 for Benny, and 3 for Joe, and so on. And if you can do the experiment yourself. And so this means that for random choice, we'll give 20%. But all people that have friends and has close connection, coherence, they score something like 40% accuracy. So this means that they are double as good as random to guess who it is at the other end of the line. And this is also a data that is a little difficult to explain from a point of view of consciousness only being something inside the brain.
I know there are a lot more questions, but we'll take at least one more question.
Thank you. Is there anything in quantum physics or the Buddhist philosophy that supports the idea of visualization where if quantum physics, it's been proved, is influenced by an observer, but if the observer has an expectation, does that influence the outcome? For example, if you put out positive thoughts, will positive things happen? Or if you are observing and expect either negative things or neutral things, does that thought process of the observer have any influence on the outcome?
I think yes. Why so? Because you remember from it's the observer that chooses his own situation, whether he knows or not, whether they affect or not. You remember if the observer chooses to, if we can back up, if he chooses to look at the slits, if his attention goes to the slits, for example, here, he sets up a small detector here at local level. He basically wants to sample local information, exactly whether they go through this slit or that slit. Then he would induce a situation where all quanta of energy, they will display particle-like aspects. Huh? So on the other hand, if he chooses to look at the screen up here, where he cannot make any localization, that is, he wants or he expects to sample non-local information, then suddenly you have the situation that these very same quanta of energy, whether electrons or protons, they behave as waves. So it is his choice of experiment. And this not only goes for local or non-local, it will go, as you say, with expectation for this or for that. Then nature will find and respond to that, I think. So I think the answer is yes, actually. But I don't think of I don't recall other situations like that is going for other examples than this local or non-local aspect. But I think definitely so.
I know there was at least one other question that I neglected to take, so I better give it to you.
Hi, very interesting and confusing. Being a man of an average mind, how do you
It is confusing, actually.
How do you achieve, or how did you achieve these higher consciousness? As you say, is it through meditation or scientific? I know how you got that, where you got the scientific, but the higher concentrations of, do you just achieve that through meditation, or?
I meditated a lot, and it helps with concentration, definitely. But study is also, of course, huh? One has to study. So study and meditation goes hand in hand as a monk. And you do both. Basically, it's more or less the only thing you do. So you have 24 hours free time to study and meditation. and not much else. So you do it extensively. But the thing about meditation is interesting because you say you're confused, and this will correspond to if we look at this probability distribution again. Oh, sorry. So let's say you sit down on your pillow, and then you ponder a specific question: what will happen, for example, or how is it like? Then one often doing meditation, then one after the mind has been stilled, then only one option will fall out. And then suddenly one is sure, it is like this. It is not like that, not like that, not like A, B, C, D. It is only like F. It is only like F. So one attains great clarity. I think this corresponds a little bit to looking out a situation. For example, a probability distribution. There will be almost equally big chance of seeing this outcome and this outcome and this outcome. So when we try to look out into the future, which is also partially determined, then we become confused because it looks like it could three things could happen, all with almost equal probability. And I think this is normally we will call it intuition. Huh? Doing meditation, one will be able to see, it is this probability that will fall out. And this is said about the Buddhas, not about other enlightened beings, that they can see the future, this part of the future that is determined to some extent. They can see this with complete infallibility. While we are kind of like, we are missing many things and we often make mistakes. But this doesn't say that there is not a probability distribution for what will happen. Because this physicist will say, there's a universal wave function. All our observers collectively are changing this wave function, and this is expressing it's an expression of what can possibly happen in any given future. It doesn't say of what will happen, but what possibly can happen, and how many times it will happen of this event, how many times it will happen of that event. So this, I think, why meditation is worth pursuing is that it greatly enhances your ability to see what actually will happen or how things really are. One's ability to point that out directly, not knowing it analytically. This one also use, of course, logic one also use, but in the end, if one sees it, we call it anya, then one sees it directly as it is. It is so. And then it's a very neat experience because one never forgets it and one doesn't have any problem remembering it. So it's not like academic knowledge, how was it on page 25, so on. It's not like that. It is something that you know. You really know. And this is very satisfying.
Well, thank you so much, Bhante Samāhita. That is a very fitting stopping point for the questions and the formal part of this evening's presentation. And I want to make a couple of announcements. And I don't know that it's appropriate, but I'm going to ask them to show a hand of appreciation, Bhante, because I was very kind and generous of you. And what I wanted to announce was that following on that question, so this evening we were presented with a lot of information, the relationship between Buddhist teachings, fundamental, basic, essential Buddhist teachings, in relation to many aspects of modern developments in science. And it is fascinating. And also, I must concede that for those of us who are not experts in either one of the fields, it all seems a little bit maybe confusing. But the good news is that there is opportunity. I don't think that Bhante Samāhita is going to do a class on quantum mechanics or any aspect of the law of relativity here, but he is going to teach a one-day meditation workshop on Saturday. And so that day will be devoted to actual practice of meditation, very classical form of Buddhist meditation, the anapanasati or mindfulness of breathing, which the Buddha greatly praised. and gave very explicit and clear instructions on that particular approach to meditation. And Bhante Samāhita will be presenting that on Saturday. The workshop or retreat, whatever you wish to call it, starts at 10:30 and goes through to 5. And it will be a structured presentation of an approach to meditation according to the Buddhist, this classical Buddhist method. Anyone who is interested in participating, I do encourage you to go to our website where you can actually register for the workshop. I would prefer that you register rather than just show up on Saturday morning so that we know how many people are coming. It is a whole day event, so we're not supplying a lunch, so bring your own lunch if you are coming, and that is on our program catalog there. It tells you a little more about it. So I thank you all for coming this evening. Thank you, Bhante Samāhita, so much. Wonderful start to our winter season. I hope the rest of the season is as well attended as this one. Of course, it's expecting a little too much, but if I put it out there, I will collapse the possibilities and it'll be full every week. Please stay and have some refreshments. There's tea and some refreshments there, or to mingle and, of course, ask more questions of Bhante Samāhita. Thank you all so much.
Thank you.